Work a bunch of problems on the topics and go through these. So this is Sets World. Sets World is a set is a list of elements in there, and you can turn these into real life things. This is one of those sections that maybe you won't actually draw a Venn diagram or write out a set, but your brain goes through this thought process. It is just a little bit of critical thinking here. So got some definitions here. There's 3 different forms that they use for sets. We can kind of go through all 3 of them. I'll just leave this page up so you can write down some stuff. But the roster form is the most common one. First of all, this right here, when they use brackets, is the set of, okay? So this is that when you see the brackets, technically you say this is the set of, like the brackets signify that you are talking about a set. Roster form is the most common way to do it because that lists them all out and separate them by commas, but you do have to put the brackets. So, this is saying the set of blue and white, the set of black, blue, and white, okay? So the roster form is one of the most common ways to do it, and those brackets are the set. Descriptive form, I hate using the definition, or the word in the definition, but it describes the set with words, okay? So the descriptive form, you are just describing the set with words. A refresher over some of these math words right here on this corner. Natural numbers, you'll see the words natural numbers, and I think Alex actually tells you this in the problem, so you don't have to really memorize this or anything. But natural numbers, another word for that, they call them counting numbers. So when we start counting, we start at 1. We don't start at 0, right? If we're counting something, we don't start at 0. So natural numbers are the counting numbers. That's like 1, 2, 3, 4, 5, 6, 7. And it keeps going on forever. This 3 dots right here signifying ellipses. I remember, I think when I was in undergrad, a professor yelled at us if we didn't do 3 dots because that signifies that it keeps going on forever. Got mad if you used 2 or 4. But anyways. The natural numbers, counting numbers are 1, 2, 3. The whole numbers are the same thing, but they add 0 in there. So I don't think we saw whole numbers last class. I think we just saw natural numbers and integers. Integers that add the negatives, okay? So you have all the negative numbers, you got 0, and all the positive numbers. So I believe last class we just saw natural numbers and integers, but it's kind of a stepping stone there where you do the positive numbers, then you add 0 with the whole numbers, then you add the negative numbers, and it becomes integers. So if you see those words, that's what they mean. Okay. The descriptive form right here, my examples, I believe the problem, and we'll go work some problems in just a second, but they give you the natural numbers. Well, the natural numbers are, you write it in roster form, 1, 2, 3, comma, dot, 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 and that means it goes on forever, okay? I probably should have erased this and we should have done it. But on the next part B, and we'll work problems in just a second so you'll see, but the next problem, they give it in roster form and you have to choose the descriptive form. It's a drop-down menu, so that makes it easier. But 6, 8, 10, okay? So the way we would write this in descriptive form is tell somebody what this is. We say the set of even natural numbers, because it's even and they're all positive, that are greater than or equal to 6 and less than or equal to 10. Okay, greater than or equal to 6, less than or equal to 10. Technically, there's probably multiple ways you could say that. You could say, I don't want to go into that too much, but you could say the set of natural numbers or even natural numbers that are greater than 5 and less than 11, because then you're finding every even number between 5 and 11. So you could there are kind of a couple different ways you could say that, but this is a drop down menu on Alex, so it should make it easier. So the last one, I didn't have a good definition for it. I probably should have looked it up, but I just wrote the mathy way to do the descriptive form, okay? Mathematicians are, I'm going to say lazy, but that's because they just want to write things quick. When they're writing stuff, they don't want to write a bunch of words. The story behind that, or the quick story behind that is, I remember hearing this a long time ago, but Bill Gates, when he actually worked, I'm not saying he doesn't work now, but when he was very involved with Microsoft, he'd always go, when he wanted something done, he'd always go find the laziest person to do it because they were the most efficient. They wanted to do it and get done, so they do it the quickest way. So that's always reminds me of mathematicians. They always want a short thing. So they don't want to write all this out, right? So what they do is they do this set builder form right here. The set builder form is not something that you'll have to do, but you might have to read it just to know what it is, so I wanted to go over it. So again, the brackets mean set of, and then they name it. So the first thing is like to name it. So like last class I saw an X here, I saw a Y here, that names it. Then they do a vertical line. The vertical line means such that. So the set of X's such that, and then they give it a condition that describes it. So here, X is a natural number and it's greater than or equal to 5. Okay? So it's a set of X's such that X is a natural number and greater than or equal to 5. Like I said, you're not going to, so the answer to that would be greater than or equal to 5. We'd start at 5, 5, 6, 7, and goes on forever. You won't have to, I don't believe you have to ever write it in set builder form, but you will see that. So again, that names it such that, and it gives it a condition of what it is there. I'll pause for just a second, let y'all get all that written down if you want to.
This is in the that notes.
Yeah, it's in the Apple Notes folder. It should already be there. Oh. All right, I can come back if I need to. All right, let's go do some problems on these definitions, and we'll come back. All right, so the first one is identifying elements of a set in real-world situations. So again, like you might not actually write these out, but you're going to think about this. So give the set of servers who served between 20 and 35 customers at lunch. So you got to identify the lunch column. And between 20 and 35 would be like these three right here. So you have to do the brackets. And then it was 20 and 35. So Lucy, Chow, and Yoko, 20 and 35, that looks right. Okay, so you just do that right there. Just make sure you do the brackets. Give the set of servers who served more than 70 customers at dinner. These are from least to greatest, so that makes it easy. But again, bracket, 70 or more would be Bob and Ann, right? Bob and Ann. And we have our answer. So again, this is just roster form, making sure you use the brackets and do that. Talking about roster and descriptive here. So there, like I said, it kind of tells you what a natural number is, but it's just a counting number. So here, they give us a descriptive and we got to do roster. So the first thing is we want the brackets. The set of odd natural numbers greater than or equal to 5 and less than or equal to 11. So it's greater than or equal to 5, so we start at 5, and then we go up to 11, and it is greater than or equal to 11, okay? This one gives me the roster form, and I have to use a descriptive. So just drop it down real quick here. It starts at 3. So and it's natural numbers because they're all positive. So it's a set of natural numbers greater than or equal to 3. And we do greater than or equal to 3 because it does have that dot, dot, dot. So it does means it goes on forever. It doesn't stop at 6. It keeps going. All right, so here's your first like set builder one, but again, it's not too bad here. So X, the set of X is such that X is a natural number and X is greater than 3. So again, you got to click the bracket to make sure you signify that it's a set. And then greater than or greater than 3, we start at 4. So 4, 5, 6, and it says list the first 4 elements. So 6, and then I do comma, and it's got the little ellipses there. Or I do dot, dot, dot. So it goes on forever. This one, you just got to be careful with your less than and less than or equal to. So 13, 14, and 15, natural number. It's saying Y, but that's fine. So it'd be this one right here, less than or equal to 13, less than or equal to Y, less than or equal to 15. Let me try another one of those real quick. Let me see if I get... Oh, this one kind of can mess with you a little bit. That one we already did. Greater than or equal to 6, so you'd start at 6. But the descriptive form on this one, 1, 2, 3, 4... I mean, like my first thought is that, but they don't have less than or equal to, right? And we don't have to signify that it stops at 1 because natural numbers start at 1, okay? That's the beginning. So it's actually going to be this one right here. Y is a natural number and Y is less than 5. So we only have to do less than because we know it stops at 1 anyways because it's a natural number. So 1, 2, 3, 4 would be all the natural numbers less than 5. So if you're counting all numbers less than 5, basically. All right, moving into another real world one. This one's kind of a pain, but you just got to read this. And again, this is the thought process here why we do something like this in this class is no, you may not write all this out and write it in set form, but just the thought process of reading all these. So here, I'll read these real quick. Kim is offered on both Monday and Wednesday. So what are we doing? Tutoring. So Kim is offered on Monday and Wednesday. Stats is offered on Monday, but not Wednesday. Art, English, and German are offered on Wednesday, but not Monday. Bio, Econ, Math, and Psych are offered on neither Monday nor Wednesday. Okay? So descriptive form, the set of subjects not offered for tutoring on Monday. So we do the brackets to signify a set. Well, I know Bio, Econ, Math, and Psych are all not on Monday nor Wednesday, by that last line, right? So which other ones are not offered for tutoring on Monday? Art, English, German are offered on Wednesday, but not Monday. So Art, English, and German. Okay. Then you go the opposite. They give you Kim, Art, English, German, and which ones are those offered? Kim is Monday and Wednesday. Art, English, and German are Wednesday, but not Monday. So they're all on Wednesday, maybe? Yeah, I think I like that one. They're all on Wednesday, right? Because Kim is Monday and Wednesday. Art, English, German are offered on Wednesday, but not Monday. So yeah, it's the stuff that's offered on Wednesday. Stats, Art, English, German, Bio, Econ, Math, Psych. Bio, Econ, Math, Psych is the ones that are not offered either. Stats is on Monday, but not Wednesday. Art, English, German are offered on Wednesday, but not Monday. Oh, okay. So what is our answer here? Bio, Econ, Math, and Psych are not offered on... I got more options. Anybody see it yet?
Isn't it on Wednesday, not Monday?
But stats is... Art, English, German are offered on Wednesday, but not Monday. And stats is offered on Monday, but not Wednesday. What is the answer?
Would it be the set of subjects offered for tutoring on both Monday and Wednesday? Because the one above that says or about, and then Kim is not. Kim is on both, but it's not.
We don't have... But Bio, Econ, Math, and Psych are not offered on either of them. Huh. Usually it's very easy on this. All right, let's just go through it. It's not the Monday one because stats is our Art, English is not Monday. It's not Wednesday because stats not Wednesday. It's not Monday or Wednesday or both because Bio, Econ, Math, and Psych aren't either of them. It's not both Monday and Wednesday. Not offered on Monday, but stats is offered on Monday, so it can't be that one. Not offered on Wednesday. Not that one because Art, English, and German. Offered on Monday but not Wednesday. No, that's Art, English. Offered on Wednesday but not Monday. No, that's stats. Offered on both. I don't know the answer. What are they going to say is the answer? Good thing I got a solve button here. Oh, did I not scroll down far enough? The set of subjects not offered for both Monday and Wednesday. Does that make sense? I just skipped that one, I guess, because you got the not and the both. So these are not offered on Monday and Wednesday. So that's the only thing that would fit that one. So yeah, you got to be careful finding those nots and the both. So those are not offered on both days. Whew, okay. All right. One of these gets a little trickier whether you do this. This one introduces integers, so you have negative numbers, but it kind of works the same as that natural number one. So this one would be x is an integer between -1 and 3. So it's got to be this bottom one. -2 is less than x is less than 4, so it can't equal -2, so you start at -1, and it can't equal 4, so it stop at 3. Okay? And then y is an integer greater than or equal to -3. Greater than or equal to means you include it. Just got to be careful with the greater than or equal to. You do 4 of them, and then put your ellipses. That looks right to me. Okay. So just be careful with your greater than and greater than or equal to on those. I'll go back to the definition in just a second on this. Well, we can go ahead and do it. Nah, it'd make more sense to do it first. Okay, a well-defined set is a set. Never mind. A set that is a well-defined set. You can objectively determine the set. Okay, there is no subjectivity in it. Like, what's your favorite color? Or no? I don't know. Are you tired or not? That was one of the examples last class. Like, it's easily determined. Okay, so you can objectively determine it. Basically, do they give us the information in this study that we're looking at? So Amanda is a vet at an animal clinic. She chose to study 13 cats, 13 dogs out of the 40 at an animal clinic. The group she chose had cats and dogs of both sexes with ages ranging from a year old to 12. Here's the key part. Amanda recorded each animal's type, cat or dog, the weight, the age, and the sex. So that's the only 4 things we know about, okay? So determine if it's well-defined. The set of cats weighing less than 10 pounds. Yeah, she did weight. She talked about the weight, so we're good there. The set of aggressive female cats. We did not look at their behavior at all, and that might be determined as subjective, whether they're aggressive or not, but we don't know anything about whether their behavior. The set of dogs younger than 3. Did she do age? Yes, age. Okay. The set of animals in Amanda's study that were either female cats or male dogs. Yep, we did their animal type and the sex, so we're good there. The set of cats in Amanda's studies. Yes. Okay. So it's just, do they know those? I was going to try to make this one easier to read. 200 people in a wedding, family, friends, and coworkers. Made 3 categories. Each person was assigned to 1 category. Hans determined that 175 people attended out of the 200 he attended, the ones who attended and those who did not attend. So you got people who attend, didn't attend, and whether they're family, friends, or coworkers. The set of family who attended who danced well. We didn't do anything about their dancing, right? The set of people who attended who gave good gifts. Again, those are both subjective, whether they danced good or not, or whether you got a good gift or not. The set of coworkers. Yes, that was one of our categories. The set of likable people. That's one of the categories. That's pretty subjective. And the set of people who attended who were poorly dressed. A lot of those are. Did I click yes on that one? I didn't, did I? So that one has a lot of no's on there, but you can only answer the question if you can for sure see it from their data and whether it's just objective. All right. Yeah, we can do all 4 of these definitions real quick. A cardinality means that you count how many are in each one. So cardinality, the definition is the number of elements in the set. I don't know what word I was trying to write there, but that's number of elements in the set. Okay. And the way they write that, so the cardinality is something you'll see a lot because it does help us determine. We'll see that a lot next week when we're looking at Venn diagrams and stuff. But the way they write that is N of A right here. So when you see this N in front in parentheses, that's saying the number of elements in A. Okay. So eventually they stop telling you to find the cardinality and they just put that N of A, and you got to know that that N of A is the number of elements in there. Below that, you got a couple more symbols. And this weird looking E is an element of, okay? So the example makes more sense. Blue is an element of A, okay? So blue is an element of A. So I know blue is in the set of A. So I was talking about colors, my set may be blue, black, white, green. So blue is an element in there. And then if you put a line through it, just like equal and not equal to, when you put a line through it, that means not an element of. Okay, so like purple is not an element of A. Okay. The way I always remember that E is it kind of looks like an E, so it's element. Blue, element of A. give you a second to write some of that down, but. Thank you. All right. So to do this, I can go back if I need to in just a second. To do this one, I would first go ahead and write down what A is to make sure you got that. So A is a set of odd numbers greater than 7. So odd greater than 7, I'm going to start at 9. 9, 11, 13, 15, 17, 19, 21. Less than 23, I'm going to stop before there. So less than 23. So odd numbers greater than 7, less than 23. So it is nice to write those out because you got to count them anyways. So the cardinality of A, you just go count them. 1, 2, 3, 4, 5, 6, 7. So I have 7 of those. And then the cardinality of B, I got 1, 2, 3, 4 of those. So cardinality just means to count. Again, you're going to just know that symbol means the number of those. Select true or false. 13 is not an element of A. Well, 13 is in A, so that would be false. 15 is an element of A. Yes, 15 is right there in A. That is true. W is an element of B. Yes, it's right there. So that is true as well. C is an element of B. I do not see a C in here. So that is false. Okay. So really this one's just all about the symbols. Shouldn't be that difficult. Just got to know those different symbols. Wait just a second. Was there one more? There was one. All right. This one I don't think will mess with you too much. You just got to count on here. You just got the words finite and infinite. So like, well, we'll do B or A first. So you can count the elements in A. 1, 2, 3, 4, 5, 6, 7. So there's cardinality is 7. For B, it's 52, 53, 54, 55, and then goes on. And it goes on forever. So this is going to have an infinite amount of numbers in it. Okay, so you can't really count that. It's just an infinite. The cardinality is infinity. The set of integers greater than 16, well, any number greater than 16 would be infinite. Okay, I feel like this one has a hard one. Oh, there it was. I think I just skipped past it. Yeah, so like A... like there is an ending to it. We haven't seen one like that, but that would be 15. The cardinality would be 15 there. B is infinite because it goes on forever, and then the greater than we did both of those. But just I saw A. So like you can count all those 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 all the way to 15, and there are 15 there. All right, last definitions. The first one, equal sets. For sets to be equal is kind of a duh. For equal, the sets have to be exactly the same. They have to have the same elements in it, so that means they have to have the same number of items in it, okay? Or same number of elements in it, okay? So for equal sets, they are going to be exactly the same. It doesn't matter if they're mixed around. A is 7, 8, 9. B is 9, 8, 7. So the equal is kind of a duh. The new one here, though, is equivalent. Equivalent sets have the same cardinality, okay? They have the same number of elements in it. So they are equivalent if they have the same number. So my example here is A is 1, 2, 3. So my cardinality for that is 3. And B is bird, fish, cat. Okay, those obviously aren't equal, but the number of items in B is also 3. So the cardinality for B is 3. So they would be equivalent because they both have 3 elements in it. Okay? So equal, like I said, it's kind of a duh. They got to be exactly the same. Whereas equivalent, they are equivalent if they have the same cardinalities. Okay. I think this goes a lot deeper in math than we'll go, but like you'd use that for a lot of different reasons. You can map them and do all sorts of different things if they have the same cardinality. Give you a second, that's fine. All right, a couple more topics. I'll be about halfway done, so we finish the rest Thursday. So on these, you may need to write these out, but we can probably think about it. The set of odd numbers greater than 18 and less than 26. So 19, 21, 23, and 25. 19, 21, 23, and 25. That's 4. 19, 21, 23, 25. Yeah. Okay, so that's 4. You got to know how many is there. Obviously, they're not going to be equal because the next one is a set of integers greater than 4 and less than 9. Okay, but greater than 4 would mean I don't start at 4, so it'd be 5, 6, 7, 8. Okay, so I do have 4 in both of them, so they would be equivalent but not equal. Okay, so equivalent just means they have the same count. A is a set of integers greater than 5 and less than 9. So again, don't count 5, 6, 7, 8. 6, 7, 8 is only 3 numbers, and then B has 10, 11, 12, 13. So obviously they're not the same. So this is going to be neither equivalent nor equal because A has 3 and B has 4. Part C looks the same to me, doesn't it? 23, 24, 25, 26. So this is both equivalent and equal. If they're equal, they're going to be equivalent because to be equal, they have to have the same amount in there. And then tell me what D is. Equivalent but not equal. They both have, they're not the same, obviously. One's DFG, the other's GMN. But they both have 3. Their cardinality is 3 for both of them, so they're equivalent but not equal. All right. 8 passengers from the United States aboard an international flight compared their travel experiences. So choose a set that is equivalent but not equal to the set of countries that Chris visited. So Chris is Thailand, China, Morocco. We don't want to choose exactly the same, but the cardinality is 3. So what about any other one that's 3? What, Lamar? Lamar, Poland, Panama, Ethiopia has 3. So as long as they both have 3, they are equivalent. Choose a set that is equal to the set of countries that Deshaun visited. Deshaun is India, Japan, Russia, Korea. Is there another one of those? India, Japan, Russia, Korea. Pablo? So those are exactly the same. Find 2 passengers whose set of countries visited are neither equal nor equivalent. So I'm going to go with Ashley as my first one because Ashley has 5. And then just pick any one that has a different amount. So Ali has 2. So obviously they're not equal. One's 5, one's 2. Cardinalities don't match, so they're not equivalent. Okay. All right. That